Right, so I'm going to talk about CDImage. Example in the right hand corner is okay, so CDImage is a program that originally someone in Russia made a program called CDPaint. The idea was that you had access. The idea was that you could use an audio file to generate an image. So a guy in Russia made a project, CDPaint, and then someone else came in and took that code and converted from C to C++, added a GUI, and became CDImage. Both of them still suffer from a problem with calibration. So every CD from every brand is slightly different. And for the program to paint an image, it needs to calibrate two variables. And the original program, CDPaint, it had calibration code. It was basically a binary search, which meant you'd have to do like 20 burns and then inspect the CD. And the thing in the original program, the thing you were looking for in the CD was so tiny that I couldn't do it. So I was like, screw it, there's got to be a better way. So in my great wisdom, I decided to do my own approach, which was, go on.
Every CD writer or CD blank CD?
Every blank CD. So every brand is different, and then within the brands, so you can have different burn speeds for CDs. So let's say if you went, I don't know if Philips has CDs anymore, but let's say brand A, it could have 4 times speed, 10 times speed, 20 times speed CDs. They could all have different calibrations. Majority of the time, you buy a pack of CDs, they should be similar. That's all you can guarantee. If you buy it one year and then buy the same pack the next year, I don't know if you can guarantee that. The calibration is important. So get rewritable CDs and make them high speed, because I was an idiot and got low speed CDs, which meant 20-minute burns. You burn 10 times, they go to your afternoon. So there are 2 variables to calibrate. The first variable, so you're burning a 800 megabyte audio file to a CD. The first variable describes how much of that data is the first loop on the CD. So it's like, how many bytes will do one loop around the CD, and the second variable describes how that size changes for each loop. So eventually, there's more data on the outer rings than there is on the inner rings. So it's just an equation to describe that, and you're trying to figure that out. There was a lot of possible ideas about figuring this out. The main one I originally had was, okay, I can just scratch a straight line on the CD, rip the CD, and then figure out from the rip data what variables make a straight line. I was an idiot and I scratched the bottom of the CD, which ruined my CD burner, which I had fixed, so it should be able to work now. But the other issue with that is the CD is actually pretty good at error checking. So what's better than to do that is you have to write a track to it that makes errors very obvious. So if you scratch like a line into an audio file, if it's just a normal audio file like a sine wave, when it does error checking, it will just interpolate the bits that are missing. So it's best to burn like a file that's like really random and then compare. So you like burn a random data, scratch it, rip it back, and then see the difference. You burn like a sine wave or something, scratch it, rip it back. It will interpret those errors. You won't find those errors. But I couldn't do that because I broke my burner. So I was stuck with this way, which was burning a calibration image to a CD, looking at the image that was burnt onto CDs, which you can see passed around, they are spirals, and from that figuring out what the parameters were. I came up with a solution. At the same time, someone else online came up with their own solution. I definitely think their one is a lot faster because my one was originally based around ripping data, so it's a lot slower. But I've rewritten it, it's still in progress, so I'm going to focus on someone else's solution at the moment. And the idea of the way it works is, on the left hand side, this is the target image that you will burn to a CD. In the middle is simulated what a burnt CD would look like if your parameters are incorrect. So if you burn this to a CD, you end up with something like that, and it creates this, what we used to call a spiral, but isn't actually a spiral because it can randomly change directions midway through onto a CD, and then there's a Desmos script to figure out, based off how much the spiral turns, what the original parameters of the CD are. Which, on paper, really easy to do. In reality, kind of sucks, because you can't see anything, and if you're like me and thought it was a good idea to get a big flashlight, you get a stupid flashlight in the eye because it just reflects. So it's really hard to kind of access that data. I did have an idea around how to do that by keeping a static camera, moving a light source, and incorporating it over time. But it's a pain. So that's why we use this system of like rings. So you can use the rings to describe where they are, and you don't need to take a photo. You say, oh, from ring 4 to 5, it's moved about 5 or 6 degrees. Write it down. This is a bit easier than taking a photo because you can't really take a photo with the camera, and you also can't scan a CD. The other solution is you can draw a line on a CD with an erasable pen, scan that, and then look for the line, and then draw it in Photoshop and do some other calibration. But essentially, once you run this calibration maybe 4 times, you kind of get a straight line, but it's not super straight. The program I am still writing and working on, it's trying to solve that last little bit of wobble, but still in progress. So my method was, okay, instead of counting the rings, it would be to capture the data or the photo on the CD and just run some form of registration, or keep simulating until your parameters match. The main issue is it's hard to capture the CD. So currently I just draw with an erasable marker, scan that data where only the marker appears, and then run a fit solver for it. On the left hand side, this is like the target line you want to match to. On the right hand side, you have the blue, which is the solution, and it kind of matches, but initialization is, I did a matching in a different space. The initialization is important. So if this is your target, but you give it a bad initialization, the registration can kind of get stuck between 2 lines. That's just something I've got to work on. It's just the way I've written the code, which I can solve later. But this is the main reason why you can't really scan it. So those CDs I passed around, this is what it looks like when you put it in the scanner. Those black lines are where that spiral was, and you drew over it. So you can't scan it. So the next idea I was looking at is having a moving light source, and then from that extracting those rings. It's something to look into. But it's still in progress. If you want to do this at home, you can. I recommend using a scanner. You just take the target image, burn to a CD, draw the spiral on it, scan it at your local, if you have a scanner still, scan it at home. Otherwise, go to a convenience store, get really funny looks as to why you're scanning a CD. Scan said CD, open it in your favorite photo editor, Paint. Mark the points, determine the angles for every ring. So there's like rings along here. Mark those points, put it in the Desmos program, and you'll get an output answer. Do this maybe 3 or 4 times, and you'll eventually get a solution that works, and then you can draw images onto it. Oh yeah. This is the current GitHub issue page. I think it's pretty obvious as to where most of the progress is happening. Although it's less of a GitHub issue and more of an IRC chat, people tell each other good night in there, so it's kind of really weird. But yeah, that's about it. I think there was one CD where I burnt the TLUG logo onto it. So if you do want to look at it, you can see you can get pretty high resolution on the CD. Yeah, I realized this is kind of out of order, but yeah, that's about it. Questions? Any ideas of better ways to solve it? I kind of didn't want to take up too much time because I didn't realize there was food here, so yeah.
I was gonna ask, is there a big community around?
No, there's like 3 people. It's like one guy in France just wrote their code. Myself, which is wrote my code. I haven't released that yet because it's not good code. The original code like took 20 minutes to run. Now it runs in less than a minute. Besides the point. And then like 2 other guys. I think they're in America. Yeah, this is about it.
And you produced 572 comments on
yeah, it's and there's like good 30 of them is good night, and I'm going to bed now. It's kind of weird. I try to keep all my posts there, which very factual based and not like that. But yeah, that's what I've been working on.
Can you also use like any burner?
You can use any burner. You can only use CDs, not DVDs. But you can use any burner. I recommend getting a high-speed CD because if you do what I did and buy cheap pack CDs, 2 times speed CDs take about 20 minutes to burn 800 megabytes of data, which assuming you take maybe 5 burns, that's like an hour or 2. And that's if you know what you're doing, like you can kind of take a bit longer. There is a README that is being updated, so this is all explained, so you don't have to go through those 572 posts. So there's a pull request for a README, use that if you want to do it. But otherwise it's pretty fun. Yeah, the whole reason why this is normally I work on like embroidery and embroidery machines. When I moved to Japan, I couldn't really bring my machine with me because it would take up all my luggage space and be very expensive because it weighs a ton. So I kind of wanted to work on something similar. I was like, well, this would be a fun project and it sounds very solvable and easy to do. Yeah.
Is there any advantage maybe to using like the HP LightScribe drives? And is it possible to like decompile like the old HP LightScribe applications and see what they're doing? Or?
I don't have a LightScribe. I don't even know if I was alive when they came out. Like, so there are people that were thinking about that, but it was more of I had this on hand, I had my own burner on hand. I didn't want to buy a LightScribe. I also not too confident at decompiling driver code Linux, so I kind of worked with what I knew, and yeah, that's going to be the focus.
Gotcha. Thanks for making me feel old.
I have a business idea for you.
Mm-hmm.
So what you do is you hook up with one of these indie bands or something, or maybe even AKB48, and when they put out a CD or a DVD, every 50th one is not a CD anymore. It's a picture of the band, and you take it in and you get a signed CD.
This kind of reminds me, I think there was an album recently where someone burnt to a clear CD and then none of it played because it doesn't have a reflective layer, so there's no audio.
There's a YouTuber who has a great, with oscilloscope showing the difference between the reflectivity of one and the other.
Yeah.
High pattern sucks on the new one.
Yeah, it kind of makes sense. I think if you were AKB48, then you just buy a LightScribe. We're in Japan, they probably still sell them in a shop somewhere. But yeah, there was the idea of you could mix the images with audio. The issue is you're interfacing with the burner. You give it an audio file. It has its own encoding, so it's not a one-to-one thing. The binary data you give to the burner is not the binary data that's written to the CD. There's a form of encoding, there's also a form of error checking. So it'd be hard to burn an image, yes. You could possibly burn an image and the audio and get them both to play at the same time, but you need to override the drive or access the CD internally and manually burn the bits into the CD. Yeah, that's too much. Firmware hacking for something you can't see. Yeah, I don't have an oscilloscope. So yeah, there's that.
Sorry, I have a question.
Sure.
So you are using the CDRW CD. So is it it can be burned multiple times, but can you clear the image on the CDRW?
Oh yeah, it's just your normal way. So I think it's CD record. You can do a fast clip. Like yeah, you can clear it. I brought my burner. I can just if people are really interested, I could probably give it away a CD. If you got an image, I could burn it if you want to wait 20 minutes. But yeah, you just clear it. The clearing's fast. The burning takes however long it is, depending on your CD. Yeah, you can do it multiple times. Or you can buy a packet of CDR and burn through the packet. People have done that. Depends. Yeah. Okay. Yeah, that's about it.
Thank you.
Yeah.